Check, 1, 2, Jake. Do. Doing some CodeCademy. And then some JavaScript and Phaser. Let's double check this. Let's see, there we are. And we're live. All right. Welcome back, everyone. We're going to be jumping back into JavaScript today using CodeCademy. Been going through the course on creating video games with Phaser.js. This is sort of a library inside of JavaScript that can be used for browser-based video games to make those developments a little bit more efficient. Last time we went over a cube matching game. That one, honestly, was probably the most frustrating of the development projects that we've tried so far. The other two games, or I guess 3 games, that we coded were a little bit more fun, more self-explanatory. This last one was definitely more challenging. But if you want to take a look at that, that's on Twitch, and then it will be on YouTube after that. Also, if you want to check on any of the rest of the course that we've gone through, go ahead and check back on YouTube with the same channel name, Noctophonics, and you can learn with us from the start to the finish through JavaScript. But for today, we are going to jump into the objects portion of this course. We've learned about iterators, functions, loops, etc., but now we're going to learn about objects. All right, objects are extremely important ways to store and represent information. Objects are useful in so many ways. One particular use case is to represent real-life things in code. For example, users on a website can be represented as an object. That object would have to contain the memory properties that make up the user, information like their name, username, email, etc. Similarly, we can apply the same thought to using objects in games. Need some characters in your game? Maybe some equipment? How about trees? Each of these things can be made into objects that interact with each other. Master objects and you'll be well on your way to creating robust programs and games. All right, let's get started. Welcome back, CodeCademy. All right, introduction to objects. It's time to learn more about the basic structure that permeates nearly every aspect of JavaScript programming. Objects. You're probably already more comfortable with objects than you think, because JavaScript loves objects. Many components of the language are actually objects under the hood, and even the parts that aren't, like strings or numbers, can still act like objects in some instances. There are only 7 fundamental data types in JavaScript, and 6 of those are the primitive data types: string, number, boolean, null, undefined, and symbol. And we've looked at all of those except for null. I don't think we've come across a situation where we actually use null. We've looked at undefined before. Booleans are true or false. Number is self-explanatory. String is any language that you want to put in, just words. And then symbol, I don't know about symbol. I don't know if we've gone over that specifically. But with the 7th type, objects, we open our code to more complex possibilities. We can use JavaScript objects to model real-world things, like a basketball, or we can use objects to build the data structures that make the web possible. At their core, JavaScript objects are containers storing related data and functionality, but that deceptively simple task is extremely powerful in practice. You've been using the power of objects all along, but now it's time to understand the mechanics of objects and start making your own. All right, so on the side here, they gave us a little PowerPoint. So we got an apple with properties of red, species of Fuji, and its pest is this worm. This worm has properties of its favorite food, which is apples, and his name, Wormy. And then we have a table with its properties of number of legs and material, 4 and wood. And then we have a baby, properties of the name Leo and weight 6.2. All right, creating object literals. Objects can be assigned to variables just like any JavaScript type. We use the curly braces to designate an object literal. Let spaceship equal curly braces. Spaceship is an empty object. We will fill an object with unordered data. This data is organized into key value pairs. A key is like a variable name that points to a location in memory that holds a value. So you look for the key within the object, and that gives you the value. That is something some type of data stored in the memory. A key's value can be any data type in the language, including functions or other objects. We make a key value pair by writing the key's name or identifier, followed by a colon and then the value. We separate each key value pair in an object literal with a comma. Keys are strings, but when we have a key that does not have any special characters in it, JavaScript allows us to omit the quotation marks. All right, so they give us an example here. What it looks like in the code is down below. All right, so they have let spaceship equal. Now, when they are basically declaring an object, right? Declaring an object literal, all you need is these curly braces, and then everything goes inside of that. So we're just creating a code block like this, just with the braces, and then inside we have our keys, which are fuel type and color, separated by a colon, and this signifies that, okay, so the value is about to start, and then the value types, or the values on the side after the colon. So the key of fuel type gives us the value of diesel. The key of color gives us the value of silver. Okay, so it's pretty analogous to the variables, variable and then data type, variable and then data type. These can either be strings or just words that are without any special characters, so no spaces, just as a single word. They turn that little teal color, and that's still a key of the key value pair. All right, so the spaceship object has two properties, fuel type and color. Fuel type has quotation marks because it contains a space character. Let's make some objects. All right, so write your faster ship object literal below. The spaceship we have so far looks good, but unfortunately it's not very fast at hyperspace travel due to having an inferior fuel source. Make a new spaceship object named faster ship with the same color as spaceship, but with the fuel type equal to turbo fuel. All right, let's do it. So first we do our let. This is going to be faster ship. This is equal to a set of curly braces. Inside of this, we're going to put our fuel type. Fuel type does need quotation marks because it has a space in it. Colon, and then turbo fuel. Turbo fuel. This also is going to be separated by a comma, and that's actually very important when you're separating out key value pairs. Then we're going to put the color as the same as it was in the example, which was silver. You don't need anything at the end of the last one you do. You don't need a comma at the end of that. It's just between separate entries. Okay, let's check that. Sweet. Turbo fuel. Accessing properties. There are two ways we can access an object's property. Let's explore the first way. The dot notation. Okay, you've used dot notation to access properties and methods of built-in objects and data instances. Yes, so we've done this for like first order objects, like functions. We've also done this for strings. And for variables, we have built-in properties like length. Trying to think of any others, like you can use .map, .index, all of those built-in methods. We've been using the dot operator and then accessing something that's stored in an invisible place that we can't see. With property dot notation, we write the object's name followed by the dot operator and then the property name key. So with their example of spaceship, they have its home planet, and as you can see, even though it's two words, they camel cased it and slapped it together so that it doesn't need any quotation marks, is Earth, and then color is silver. So then you have spaceship.homeplanet returns Earth, spaceship.color returns silver. So these dot and then values, or keys rather, these keys are accessing the value stored within the object. So the object name comes first, then you use the dot operator, and then whatever key you want to access, you want to use to access the value attached to that key. So imagine all of these in boxes, and then these are the keys that you're using to open up those boxes. Okay, so object property name, spaceship.color. If we try to access a property that does not exist on an object, undefined will be returned. So if you have in spaceship.favoriteicecream, favorite ice cream is not one of the keys within that object, so it returns undefined. Let's get some more practice using dot notation on an object. Let's use the dot operator to access the value of numCrew from the spaceship object in the code editor. Create a variable crew count and assign the spaceship's numCrew property to it. All right, so create a variable. We'll go ahead and do let crew count equal. This is going to be spaceship, and we are accessing the numCrew. So dot numCrew, and I believe that's all we need. Again, using the dot operator, create a variable planet array and assign the spaceship's flight path property to it. All right, so let planet array equal spaceship dot flight path. Alrighty. Just get rid of those semicolons. I like it. Oh, yeah, I guess you need one there, eh? Yeah, okay. Yeah, so and then if we console log those variables, doesn't instruct us to do that, but I'm going to go ahead and do it anyway. Crew count and also console log the planet array. Then what we get from the crew count is what is stored within the key value pair of numCrew. That key opens up the box that has 5 in it, and then the flight path key opens up the box that has this array, which is the flight path to each of these planets. All right, bracket notation. The second way to access a key's value is by using bracket notation. You've used bracket notation when indexing an array. Yes, indeed, we have. To use bracket notation to access an object's property, we pass in the property name key as a string. So in the same way that you access the index within an array, you can do it where you access the property of an object using its key name. So the property name is fuel type, right? And that's the key in brackets besides the object name spaceship. So we must use bracket notation when accessing keys that have numbers, spaces, or special characters in them. Without bracket notation, in these situations, our code would throw an error. So if we have let spaceship equal this, active duty returns true. All of these first three, they're actually accessing keys that are within the spaceship object. And then if you put in just a string of something that is not within that object, it will return undefined. With bracket notation, you can also use a variable inside the brackets to select the keys of an object. This can be especially helpful when working with functions. Let's see here. So we have a function with two parameters. Now don't confuse parameters and properties. Parameters are the things inside of a function, the variables that you are declaring within a function, right? And that accept arguments. See, I almost slipped up there. Properties are the values of the key value pair within an object. So yeah, just keep that distinction in mind. All right, so object name and then prop name. So the way that you would call this function is you would do it normally, put in the object name as the first parameter, first argument, and then the home planet as the property name. And so what it returns is that it will access what is inside of here because you're using the bracket notation. It'll access that value box and then it will return Earth. So if we tried to write our return any prop function with dot notation, object.prop name, the computer would look for a key of prop name on our object and not the value of the prop name parameter. So that's a crucial distinction if you're trying to like make it more versatile. If you have If you wanted to access a specific key and that's all that you wanted to access, you never would need it to access anything else for that function. Using the dot property or the dot operator would be fine. However, if you wanted to be able to say you change the name of the property or change the key or whatever, this allows you to access multiple keys or use multiple keys versus just one. The dot property is just accessing one box with one key. By doing it this way, routing it into a function like that allows you to access literally all of them. You could put any number of keys in there or any one of the keys and it would return its value. Okay, so let's use bracket notation to access the value of active mission from the spaceship object in the code editor. Create a variable isActive and assign the spaceship's active mission property to it. Okay, so let's see what we got here. Field type, active mission. Okay, so let's just say let isActive equals spaceship. So it says assign the spaceship's active mission property to it, right? But it's asking us to do it in bracket notation. So brackets and then active mission. This has a space, so you need to make it a string. Active mission like so. Then using bracket notation and the prop name variable provided, console log the value of active mission property. So console log bracket notation and the prop name variable provided. Prop name, the value of the active mission property. So prop name equals active mission. Let's see that. We want to access true, right? We want to return it as true. So if we access this through prop name, so we need prop name bracket of active mission. It seems a little cumbersome. I feel like there's a more efficient way to do that, or this might just be straight up wrong. It's undefined. Yeah, let's check up here. So spaceship, because if we just return prop name, it's going to say active mission, but they don't want that. They want it to return true. So instead we do it like this, where we do spaceship, right, the name of the object, spaceship brackets, and then prop name, because the brackets are going to contain active mission, which is what that variable is now, what prop name is. So that's going to act as true. Yeah, cool. That was a good question. It helps you think about it in like the whole control flow that's happening here, looking into the spaceship object to find this property, but that property you're assigning it to a variable so that this can change in the future, perhaps like you change it to something else, so that this call or this function, sorry, not function, object reference will always work no matter the key that you put into it. All right, property assignment. Once we've defined an object, we're not stuck with all the properties we wrote. Objects are mutable, meaning that we can update them after we create them. Sweet. We can use either dot notation or bracket notation and the assignment operator to add new key value pairs to an object or change an existing property. Okay, so in this example, they're changing the value of the fuel type, right? So we're not changing the key's name, right? The property name. We're just changing the value of what's inside that box, right? Whatever that key goes to, the box that this key goes to, what's inside of that box is changing. Spaceship.color, again, we're not changing the key here. We're just changing the value within the key. One of the two things that can happen within property assignment, if the property already exists on the object, whatever value it held before will be replaced with the newly assigned value. If there was no property with that name, a new property will be added to the object. It's important to know that although we can't reassign an object declared with constant, we can still mutate it, meaning we can add new properties and change the properties that are there. So constant.spaceship. So within this, we're not going to be able to change like the fact that it is an object. Or like if you try to do it from scratch where you're reassigning, like they're doing here, where you're reassigning the whole object, it'll give you a type error. However, you can do it bit by bit. So you can access the object property and then change the values, right? So you can't do it all in one go like that. You would have to do it like in different steps for each of the properties. All right, you can delete a property from an object with the delete operator. Okay, so delete keyword spaceship.mission, and then it removes that property. All right. Reassign. If you wanted for some reason to like delete all of them and restart, you could do like a for each loop and just say for each, you know, property within spaceship delete, but or just do for loop while it exists, delete it. You know, I don't know the practical application for that, but you could do that where you delete everything and then you repopulate the object. That'd be a way around if you assign it that with a constant keyword to reassign everything within it. All right, so within the code editor, reassign the color property of the spaceship object to have a value of glorious gold. All right, so spaceship, I'll do it in dot notation for this one. Spaceship.color equals glorious gold. Without changing lines 1 through 6, add numEngines property with a numeric value between 1 and 10 to the spaceship object. All right, so with this one, we need to add a property. All right. So the way you add a property, you basically go like you're going to access it, but instead you assign it. So engines equals just between 1 and 10. So let's just go with 5 number of engines and have that work. Yeah, so if you try to access something that you know, access a key that doesn't exist yet, then it will come up with undefined. But if you are assigning a key that doesn't exist yet, it will create that within the object. It's really useful. All right, use the delete operator to remove select mission. All right, so delete spaceship dot, or sorry, secret, not select, secret mission. Okay, although wait a second, this is going to have to be within brackets because it is containing a special character. Not those, these, and then delete those curly braces. All right, spaceship brackets secret mission. Sweet. Okay. Methods. When the data stored on an object is a function, we call that a method. A property is what an object has, while a method is what an object does. It's a good way to think about it. Do object methods seem familiar? That's because you've been using them all along. For example, console is a global JavaScript object and log is a method on that object. Math is also a global JavaScript object and .floor is a method on it. So yeah, we've been using it from the very beginning, from our first day with Java. We can include methods in our object literals by creating ordinary colon-separated key value pairs. The key serves as our method's name, while the value is an anonymous function expression. So let's see, so constant alien ship, we have a key of function, anonymous function, and then we put down console log. Hello, well, we have come to dominate your planet. Instead of Earth, it shall be called New Zaculan. So with the new method syntax introduced in ES6, we can omit the colon and the function keyword, so then it just becomes invade with empty parentheses and then the code block. Once again, the same console log. Object methods are invoked by appending the object's name with a dot operator followed by the method name and parentheses. So whenever you see this syntax, whenever you see that dot operator being used, it is accessing an object, either an object or a property built in onto a data type, like the dot length property for strings or arrays. But this is a method built in with, within that object that you're accessing, or within JavaScript itself that you're using on another object. All right, so below retreat message variable in the code editor, create an alien ship object. It should contain a method retreat, which will console log the retreat message. So we have a variable of the retreat message. We no longer wish to conquer your planet. It is full of dogs, which we do not care for. That's great. All right, so alien ship object. Let alien ship. Inside of this, we're going to have a key, or well, a method, right? So not a key value pair, but a method. So retreat, which becomes the key to this. And then it's going to console log the retreat message. Okay. Should be all we need. Why is it not liking the brackets there? Oh, because I don't have an equal sign. I need an equal sign up here. There we go. Okay. Oh, yeah, we don't need that. Don't put semicolons where they don't belong. There we go. All right, so then, we're gonna add another method. So add another method to your object literal. This method take off. Just console log the string spin bar rigs blast off. So take off and just the console log of that string. Console.log of the spinboard glix blast off. I'm just going to copy all of that there. Oh, we need to, we need to add a comma. That's right, we need to add a comma between our methods. So at the end of the code block there, just add a little comma, and then you can start your new method. If we add another one, we'll put another comma here. All right, invoke your two methods. First retreat, then take off. So we're going to say alien ship, access the object, dot retreat. And make sure to put in those parentheses so that it will run as a function. And then we're going to put in alien ship, dot take off. Take off. Like so. There we go. We have our retreat message and then our takeoff message. Sweet, that's cool. That's really handy. Nested objects. In application code, objects are often nested. An object might have another object as a property, which in turn could have a property that's an array of even more objects. In our spaceship object, we want a crew object. This will contain all the crew members who do important work on the craft. Each of those crew members are objects themselves. They have properties like name and degree, and they each have unique methods based off of their roles. We can also nest other objects in the spaceship, such as telescope, or nest details about the spaceship's computers inside a parent nanoelectronics object. Okay, so here they're giving us an example of a mother object, a mother ship, if you will, right? The spaceship. Within that, they have multiple objects underneath. Telescope, they have the crew. Inside the crew, they have multiple objects, or there will be. We're going to add a few more crew members here. Engine, nanoelectronics, they have a computer inside, backup, etc. So it's cool. We can chain operators to access nested properties. We'll have to pay attention to which operator makes sense to use in each layer. It can be helpful to pretend that you are the computer and evaluate each expression from left to right so that each operation starts to feel a little more manageable. So spaceship is the object, using the dot operator to access a property within that object. Then we're saying back up, which is the key, right? So that takes it to this place here. Within the nano electronics, it takes us to the backup key. Have to use the brackets there because it's not a single word without any, or single string without any special characters. Then within that backup, we use another dot operator to access a key, and that will return lithium. So there you go. You have 4 different objects. 4 different objects you're accessing at once, or rather 3 objects and 1 key, which returns lithium. All right, so I think we went over what it was looking at there. Create a variable. Okay, so let's look over the code that they gave us. I think this was just a copy of what was on the side. It looks like it. So we have our captain here. We have our engine, our computer electronics spaceship at the top with a telescope. All right, so create a variable capFav and assign the captain's favorite food, the element in the 0th index of our favorite foods array, to it. Make sure to use bracket and dot notation to get the value of the food through nested access. Don't just copy the value into the variable. Okay, so down here, we are going to create a variable. We can just let it be let capFav. Assign this some food. So at the very top we have spaceship. So spaceship is going to be our first object. Spaceship dot, this will be crew next. Crew dot captain. And then we want to access the favorite food section within, or the favorite foods key within captain object. So with this one, we need bracket notation. Bracket favorite foods, and this will need to be within a string. Control Shift arrow key to select words at once. Favorite foods. After that, put dot. Actually, don't put dot. After that, put bracket notation. I think 0 will work here because it's an array. Let's see if that works. So let capFav equal that. Okay, cool. Yeah, so if you're working within an array, you don't need to worry about putting dot notation or like brackets around the brackets. You just put the bracket and then the index number. All right, so right now the passengers property has a value of null. Instead, assign as its value an array of objects. These objects should represent the spaceship's passengers as individual objects. Make at least one passenger object in the array that has at least one key value pair on it. Okay, so assign its value an array of objects. Do they want us to do that like outside? I mean, we could, right? Just put it on the outside. Yeah, let's try that. So we have it as null at the top here, right? Passengers equals null. So we want to change that to be an array of people. Spaceship.passengers. At least one passenger object in the array that has at least one key value pair. So reassigning this to be an object itself, right? So then we say, you know, engineer, right? Engineer. Make that a key. And then let's say like he is also an object that you know, just put the name in, right? Or just put the name in for everyone. Name. His name will be Tucker. Put that into a string. And then after your, let me give some room here so you guys can see that a little bit more towards the center of the screen. So we have our engineer. His name is Tucker. And then after the code block there for that object, add a comma. Then we'll add in, say, like security. Put in name. Name. Put in Malcolm. and then another comma, and then say like doctor. I think even with with capitals you can still put that in, but we're gonna leave that capital, put that back to lowercase, and then create name of, let's just say what's a good name for a doctor? Yes, just say McCoy, right? All right. Oh, we don't need that there. So how many people did they want? They wanted some number of people. See if that's okay. Yeah, see, they just wanted it to change. I am changing it because I'm reassigning it, but they just want it to be added manually in there, which I'll go ahead and do that. Go ahead and get rid of this bit, and just add it to the top. That would have done it in the code, and if you ran it, it would have output the same thing, but we're going to do it this way. So we're going to tab over some of our objects to make it more readable. And like that. And I think after that, we also need to put a comma at the end of the passengers object, because then telescope is next. Try that. What? Did you change the passenger's property on the spaceship object to be an array? Oh, it's not an array. It's not an array. So how do you change it to be an array? I guess it would just be like an array of people. Does this go on the outside? Like bracket notation on the outside of this? And like this? Because passengers is an object itself. Or I guess it's not an object. It's just a key. So maybe we don't need that to be an object. No, we do, because if we're putting objects within objects. So let's put these back in. Maybe the brackets go, or maybe the braces go on the outside of the brackets. Let's try that. Let's try that. No. Okay, let's do the opposite then. Let's try brackets on the outside of braces. Yeah, okay. That's it. Okay, yeah. So that's the proper notation if you want, the proper syntax if you want an array of objects. So you put your brackets to declare that this is an array outside of each individual object. And those are contained within one large object, which is passengers. Okay, cool. So create a variable first passenger and assign it to be the first passenger as its value, the element in the 0th index of the passengers array you just made. Make sure to use bracket and dot notation to get the passenger object through the nested access. Okay, so let's do let first passenger equal spaceship dot passengers, and then this is just going to be very simple, 0, right? I believe. Yep, that makes it really simple. Okay, yeah, so then you don't even have to put down the right. So like if we even did yeah, 0, so that would access the engineer object within passengers, and you don't even have to write like dot engineer. You can just write 0 because we put it into an array. The bracket notation is 0. Neat. Neat. All right, pass by reference. Objects are passed by reference. This means that when we pass a variable assigned to an object into a function as an argument, the computer interprets the parameter name as pointing to the space in memory holding that object. As a result, functions which change object properties actually mutate the object permanently, even when the object is assigned to a constant variable. Yeah, we saw that before, that we could also just change it permanently anyway, just mutate it by using the dot operators. But with this one, let's see, what do they have here? So they're creating a function that accesses the .color property of object. So it's interesting because this doesn't have any, it doesn't look at spaceship right away. All it's saying is that whatever is being passed through here, look at its color property, right? So the function, in a way, you know, just layman's terms, like the function doesn't know about the spaceship property or the spaceship object. It's just saying whatever object we have in here, access its color property. So that can be used for any object. So paint it and then spaceship, spaceship.color returns glorious gold. And that could be useful exactly for that purpose too. If you wanted to paint different objects, but you have, you know, hundreds of different objects, you can use a function, a simple function like this, to just say whatever the object is, then go ahead and change its color to whatever, and then the player could input that color, or based off of the game condition, you can change the color. So really useful just having that sort of anonymous parameter that is passed through by reference. Okay, our function painted permanently changed the color of our spaceship object. However, the reassignment of the spaceship variable wouldn't work in the same way. So try reassignment. Console log object prints false, but then okay. But then when you try to reassign it on the outside, the reassignment does not work, and the spaceship still returns this. Regular reassignment still works. So if you want to assign it regularly, then you add it on the outside of the code. Or on the outside of the function, but within a function, the reassignment is not going to work the same. You need to have it be where you have it act as a proper function and not like putting an object within a function like that. And that might be okay if you're doing like a new object, but not if you're reassigning it. So let's look at what happened in the code example. All right, we declared the spaceship object with let. This allowed us to reassign it a new object with identified and transport type properties with no problems. Yeah, so basically just reiterating what we just looked at there, with how the reassignment does not work. Okay, so write a function, green energy, that has an object as a parameter and sets that object fuel type to avocado oil. Alrighty. So let green energy. So this is going to equal and with this syntax, the object just needs to be object, right? Object equals fat arrow and then something like this. Fuel type to avocado oil. Hey, yeah, we're working on objects today. Objects fuel type to property of that. Okay, so we're going to then say object within this function of fuel type. So we'll need, instead of the dot operator, we need the brackets here for fuel type. Fuel type, this needs to be a string, and then this is just assigning that and sets that, so it just equals avocado oil. Avocado oil. It also needs to be a string. Okay, I think that works. Yeah, so this is assigning a new, or whatever object is passed through the function there, a new fuel type. All right, write a function remotely disabled that has an object as a parameter and sets or reassigns that object's disabled property to true. Okay, remotely disable. So let remotely disable. This one, again, is just going to be using You could label this whatever you like. I'm just going to put object obj in there to be the parameter. And then this one is just obj dot, because disabled is just one string, one unbroken string without any special characters, to true. And call your two functions with the spaceship object in the code editor, then console log the spaceship object to confirm that these properties have been changed. So actually I'm going to put two console logs here, but at first I'll probably do just what the instructions say, and then I'll show what it was at first, and then the difference. Yeah, it's helpful just to have the generic obj or param, right? Whatever you're working with, to let yourself know if you're looking back later, like, okay, yeah, this is supposed to be using an object in here. Okay, so we need to have our spaceship. Wait, no. We need to call our functions with the spaceship object. So green energy first, green energy. And then with the argument of the spaceship object. And then the second one will be remotely disable. Remotely disable with the argument of the spaceship objects. And then lastly, console log the spaceship. And I think, so spaceship is not defined. Green energy. Let's see, what did I spell wrong here? That's usually the issue. Spaceship is not defined. Oh, do I have to... Oh, they didn't capitalize the... Yeah, it's just one. I was capitalizing the S, the second S. There we go. There we go. Okay, so, yep. It reassigned the fuel type as avocado oil, home planet as is still Earth, but disabled equals true. So what disabled, the remotely disable function did, it not only would reassign that property, but it would also create it, right? So if we're, like we saw earlier in an earlier exercise, if we use the assignment operator, just the equal sign, for a parameter, or sorry, getting those confused, for a property that doesn't exist, then it will create that property within the object, just as you can see here. And just for extra redundancy, let's console log spaceship at the beginning and see how it changed. So at first you can see the turbo fuel was its fuel type, and it did not have a third disabled key there. And then of course you could change this to be like true or false. And after the first console log, you could have this function run again, and then it would switch it back with a property that already exists. But in this case, it added a third one. All right. Properties and methods for objects. All right, looping through objects. Loops are programming tools that repeat a block of code until a condition is met. We learned how to iterate through arrays using their numerical indexing, but the key value pairs in objects aren't ordered. JavaScript has given us alternative solutions for iterating through objects with the for in syntax. The for in will execute a given block of code for each property in an object. Okay, so we have our spaceship crew like we did before, but in this case we have a for let crew member in spaceship.crew. Okay, console log, so it will make a list of all of the spaceship crew members using that syntax. Okay, so let crew member. So in that case, it looks like crew member is it's a condition, but it's also establishing a variable. So it's like establishing a variable within this loop. And crew member is within the spaceship.crew. Okay, so let's see how they extrapolate that. So the for in will iterate through each element of the spaceship.crew object. In each iteration, the variable crew member is set to one of the spaceship.crew's keys, enabling us to log a list of crew members' role and name. Set to one of the keys. Okay, so spaceship.crew, crewmember.name. So it looks like the crew member then is being added to, okay. So the crew member is kind of like this this alias, right? That's the alias that we're using for each of the positions of the crew, right? Captain, medic, translator. And so whatever happens within this code, that's where crew member is going. It's going in the place after or within, right? So it's using that in keyword within the spaceship.crew object, and then in the next, like the next line there, the next part of the hierarchy would be the position. So captain, medic, translator. Okay. Okay. Crew member is the keys in your object. Yeah, exactly. Okay. Yep. Chat confirms. Okay, so for in iterate. Okay, so now over here, basically write our own. So we're using the for in, iterate through the spaceship.crew object in the code editor, and console log a list of crew roles and names in the following format. Crew member's role, crew member, chief officer, Dan. Okay. So let's try to do it without looking. Let's do, so they had the for, right? Then they had a variable assignment. So let, I guess they don't really tell you which, like what to use for that. We're just going to say crew member, right? Crew member, let crew member in spaceship.crew. So it's exactly the same as what they had up above for the first part in spaceship.crew. I think after this was just the code block, right? And then console log, and then we have to access that, let's see, crew member's role, crew member's name. So it's just going to be crew member, right? That's what we saw, crew member, for within bracket notation. So it's going to access that string, or we might not need, I don't know if we need bracket notation for that, but this needs to be within a string, right? So this needs to have quotations, colon, and then crew member's name, which is going to access the name property of a crew member. So within bracket notation, once again, crew member, dot name, I think, and then put the quotations at the end. That's not going to, I don't know if putting it as a string like that actually works. Let me check back. Let me check our work here. Oh, it's backticks. It's backticks and not the quotations, because we're doing a template literal. We have things other than just words. And then we need to have it be, okay, the instructions were a little misleading because they had like the brackets there, but this needs to be set as the variables like that, and then have braces on the outside of this as well. But we need to, with this one, we actually need to access the full thing. So we need to do spaceship.crew, and then the crew member is not like it's, that needs bracket notation because it's not a key. Like it is accessing a key, but it's not a key itself, right? It's like a reference to that. So crew member dot name. Okay. I think we have it good there. Just copying it down verbatim, but trying to understand it on the, Oh, sorry about that. Check M if Streamlabs deleted your message. It says that it was too long. I'm trying to look back at the other ones you sent too, but I cannot. Okay, so we have our captain, chief officer, medic, and translator. Using the for in, iterate through the spaceship.crew object in the code editor, and console log a list. Oh yeah, so crew member's degree. So we're doing the same thing, but underneath we're doing a degree. Yeah, sorry about that. Streamlabs, yeah, it's it's like, no, you cannot help out here. All right, so we're doing another one. We're saying for, this time, let crew member. Oh, I got my caps lock on. There we go. Crew member, get rid of that. Crew member within, it's going to be in the same place. We're doing exactly the same thing. In fact, I'm just going to copy this down. We know the syntax now. I'm going to copy this down and then change, instead of the name at the end, it's going to be degree, right? Like that. Console log in the correct format. Let's see. Crew member's name. Oh, they want the name as well. So they want the name at first. Yeah, okay, I see. So crew member in the first one is accessing their position, right? And then the name. But we actually want this part, so the .name to show what their degree is. There we go. Yeah, and then underneath they'll have names and then their degrees, what they'd studied to become the wonderful astronauts that they are. All right. Cool. All right, cool. Way to go. You're well on your way to understanding the mechanics of objects in JavaScript. By building your own objects, you will have a better understanding of how JavaScript objects work, built-in objects work as well. You can also start imagining organizing your code into objects and modeling real-world things in code. So what we learned in this lesson were the key value pairs. Each key value pair is a property, not to be confused with parameters. An object literal is composed of comma-separated key value pairs. Remember to put in those commas. You can mutate a property using the dot or the bracket, depending on if it's a string with special characters. You can add methods in there. We can navigate complex nested objects. Objects are mutable. Objects are passed by reference. And then the for in syntax, yes. For in, okay. Next lesson is the advanced objects. Let's see where we get to within this. Remember, objects in JavaScript are containers that store data and functionality. In this lesson, we will build upon the fundamentals of creating objects and explore some advanced concepts. So if there are no objections, let's learn more about objects. Sure, let's do it. Oh yes, we're learning about the this keyword. Woohoo, woohoo. We saw that a lot with the little game development examples. We kept seeing this over and over and over again when we were digging through, trying to find out what the errors were. Okay, so in this lesson, we will cover these topics. How to use the this keyword, conveying privacy in JavaScript methods, defining getters and setters in objects, and creating factory functions, and using destructing techniques. Okay, look over the code to see examples of the concepts covered in this lesson. Then click Next to get started learning. Let's see what we can pick up here. So at first they have a robot object with a model. See if it's mobile. The greeting, okay. Pretty simple, we saw that before. Then they have a function that contains an object. Okay, so mass prod robot. Have the shiny new robot equal mass production robot with tray hacks equals true, or tray hacks and true. I see. So then those arguments would be passed in through the parameters up here to be the model and whether it's mobile or not. And then we have a charging station. Okay. Set as another object. Set robot capacity. Oh, this is interesting. So that's a set keyword and then a get keyword. I'm not going to try to dissect all of this right now, but these are our getters and setters. So this is probably the function factory, they said, the function factory. And then these are a little more mysterious at this moment. We'll learn about those. All right, the this keyword. Objects are collections of related data and functionality. We store that functionality in methods on our objects. Constant, goat, diet type, herbivore, make sound, console log, ma. Okay, so in our goat object, we have a make sound method. We can invoke the make sound method on goat. Goat.makeSound prints ba. Nice, we've got a goat object that can print ba to the console. Everything seems to be working fine. What if we wanted to add a new method to our goat object called diet that prints the goat's diet type? All right, so constant goat, diet type is an herbivore, make sound, goat diet. So if we try to access that as a function or as a method, the output will be a reference error. Okay, so diet, console log diet type. Why is diet not defined? So usually a setter, from the chat, usually a setter is to collect or modify a value, and a getter should return that said value. Yeah, so we're going to learn about those here in a second. Okay, so why is our diet type not defined even though it's a property of goat? That's because inside the scope of the diet method, we don't automatically have access to other properties of the goat object. Here's where the, okay, so it's like they have different scope. So this still has function scope. It doesn't have object scope, right? And like these aren't visible from other functions either. Yeah, that's interesting. Okay. So then you would have to put in like your, without using this, you'd have to put in like goat.diet type, I guess. But instead of doing that, here's where the this keyword comes to the rescue. If we change the .diet method, use the this, the diet works. So console log this .diet type, using that then works correctly when you say goat.diet, outputting the herbivore value from diet type. So that's where the this keyword comes in. It accesses things within the object that this this function can't see. All right, so the this keyword references the calling object, which provides access to the calling object's properties. An example above, the calling object is goat, and by using this, we're accessing the goat object itself. And then the diet type property of goat by using property dot notation. So let's get comfortable using the this keyword in a method. Okay, so let's create a new object to practice using this. We've got our robot here. Add a property of model and assign it to the value of that and energy level. Okay, so let's just do that first. So model, we're assigning it 1E78V2. Okay, that needs to be in a string. And then energy level. And this is going to be 100. Okay. So far, so good. Inside the object, add a method named provideInfo. Inside the body of provideInfo, return the following string by using interpolation. I am model, and my current energy level is energy level. Replace those with calling the object's model and energy level properties. And to get access to them, we are using the this keyword. All right, so we have our energy level. We're putting down here provideInfo. Info, this will be a method. And within this, we have the string. So console log. Or it says return, but I'm going to console log it because I assume we want to actually see it. Console log backticks, we do I am robot dot, or no, this, but we need to put this into braces with a $sign in the front. This dot model, and my current energy level is, and then put in again template literal with, let's see, this dot energy level. Okay, let's check on that. No. Okay, so let's see. So did you return? Okay, so they do want to return that. They don't want it to be console logged for some reason. So let's just return the string of this. There we go. Just return that. Ta-da! Now, to check provide info has access to the internal properties of robot. Log the result of calling provide info on the robot to the console. So down here, console log robot dot provide info, and then this of course needs to be needs to have parentheses at the end to access the method. If not, it's just going to give you, well, if you do that, it's just going to give you a reference error. If you do this, it's just going to show you that it is a function, but you need to add those parentheses to actually run the function, and now it will give us that string. So it will give us the model number and the energy level equal to 100. This was using the this keyword. Okay. Arrow functions and this. We saw in the previous exercise that for a method, the calling object is the object the method belongs to. If you use the this keyword in a method, then the value of this is the calling object. However, it becomes a bit more complicated when we start using arrow functions for methods. Take a look at the example below. Okay. So we have our goat object here. We got its diet type. We got its make sound. So then we're using an arrow function, prints undefined. Yeah, I don't know why you would need to do that if we're just like using it as a method, right? If we're just trying to call the method here, why you would need to use arrow syntax at all. You just use the empty parentheses, make it a method. But in the comment, you can see that goat.diet would log undefined. So what happened? Notice that .diet method is defined using an arrow function. So arrow functions are inherently bind or tie an already defined this value to the function itself that is not calling the calling object. Okay? In the code snippet above, the value of this is the global object, or an object that exists in the global scope, which does not have a diet type property and therefore returns undefined. Okay. And already defined this value to the function itself. Yeah, so then that's trying to access a global object. So it's looking at this as a global object and not goat. And then it's saying that access the property, it doesn't exist because this doesn't actually exist as a global object, so it prints undefined. Okay. To read more about either arrow functions or the global object, check out the documentation. Cool. The key takeaway from this example is to avoid using arrow functions when using this in a method. Yeah, or just, yeah, just, I don't know when there would be a case. There probably is, but I don't know when there would be a case where you would rather have an arrow function than just the method syntax that we were seeing. So we're just going to change that to a method. And yeah, so currently the check energy method is not producing the correct output because it is using arrow function syntax. Refactor or change the method to use a function expression. So just like this, I believe. You can write the function using either longhand or shorthand format, and after refactoring, notice that check energy has access to the other internal properties of the robot object. Yeah, so this this now is being used as robot, or it's referencing robot instead of referencing like this global object floating out in space that doesn't have properties of energy level. Okay, so then once we change that, then it shows that energy is currently at 100%. All right, privacy. Accessing and updating properties is fundamental in working with objects. However, there are cases in which we don't want other code simply accessing and updating an object's properties. When discussing privacy in objects, we define it as the idea that only certain properties should be mutable or able to change in value. Certain languages have privacy built in for objects, but JavaScript does not have this feature. Rather, JavaScript developers follow naming conventions that signal to the other developers how to interact with a property. One common convention is to place an underscore before the name of a property to mean that the property should not be altered. Here's an example of using the underscore to prepend a property. So constant bank account with an underscore of amount of 1,000. In the example, the amount is not intended to be directly manipulated. Even so, it is still possible to reassign the amount, which would be completely wonderful. Bank account dot amount equals $1 million. Let's go. Let's go. I know code now. I can change my bank account. No, because encryption is a thing. Okay, in later exercises, we'll cover the use of methods called getters and setters. Both methods are used to respect the intention of properties prepended or begun, that should be begun, with underscore. Getters can return the value of internal properties, and setters can safely reassign property values. For now, let's see what happens when we change properties that don't have setters or getters. Okay, so below the robot object, reassign the energy level property to high. Okay, so robot dot energy level equals high. Okay, now take a look at the new recharge method in robot. Recharge will add 30 to energy level. Okay, call recharge on robot to find out. So this isn't going to work because it's going to be like the string added to a number, right? So it's going to print like not a number, NaN. So let's confirm that. So robot recharge method Oh, okay, so it didn't return not a number, but it just slapped it together. So it said high and then 30. Notice that a funky string is printed to the console. This is known as a side effect of type coercion. No need to worry about what this means for now, but it's important to understand that you can cause unwanted side effects when mutating objects and their properties. So be careful. Yeah, that's interesting. I would expect that, like if you're trying to like mash a string and a number together, that it would just say, yeah, this isn't a number, undefined, whatever. But it did actually create a string. It's just interpolating it as you wanted everything together as one. All right, getters. Getters are methods that get and return the internal properties of an object, but they can do more than just retrieve the value of a property. Let's take a look at a getter method. Constant person. Okay, so we have some names that should not be changed, right? They're not intended to be changed with that underscore. That's what that's telling us. Get full name. If this dot first name and this dot last name, if those are both true, return those, else missing a first name or last name. So person dot full name is then John Doe. Okay, so notice that in the getter method above, we use the get keyword followed by a function. We use if else conditional to check if both the first and last name exist by making sure they're truthy, and then return a different value depending on the result. Okay. We can access the calling object's internal properties using this. In full name, we're accessing both first and last. In the last line, we call full name on person. In general, getter methods do not need to be called with a set of parentheses. Syntactically, it looks like we're accessing a property. Yeah. Okay, so get full name. Yeah, it looks like you're just accessing a property versus like if you didn't have get, then you just like labeled this just full name, then it would operate as a method and you would have to put parentheses here. But since you set it as a getter, a get method, then you don't have to put in the parentheses at the end there. No, I'm so sorry. I am going to change that. I don't know what the limit is on there. Sorry for the inconvenience. Okay, notice that in the getter method above, we use the get keyword followed by a function We use an if-else conditional to check if both first name and last name exist by making sure they both return truthy values and then return a different value depending on the result. Okay, we can access the calling object's internal properties using this. In full name, we're accessing both this first name and this last name. In the last line, we call full name on person. In general, getter methods do not need to be called with a set of parentheses. Syntactically, it looks... Oh yeah, we already read all that. Got distracted. Now that we've gone over our syntax, let's discuss some notable advantages of using getter methods. Getters can perform an action on the data when getting a property. Getters can return different values using conditionals. In a getter, we can access the properties of the calling object using this, and the functionality of our code is easier for other developers to understand. Another thing to keep in mind when using getter and setter methods is that properties cannot share the same name as the getter and setter function. If we do so, then calling the method will result in an infinite call stack error. One workaround is to add an underscore before the property name, like we did in the example above. Great, let's go getter! Ha 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 ha. Yeah, okay, cool. Putting an underscore there instead. Okay. So in robot, create a getter method named energy level using the get keyword. Leave a function body blank for now. All right. So inside of this, we're going to put get energy level. And then set up like this. Okay, I think that should be all good. Yep. Inside the method, add an if statement to check that if this energy level is a number using the type of operator. If that's truthy, return this string and then replace energy level with the value of this energy level. Okay. And make sure you return the string and not logging it to the console. All right, so inside of this, do an if statement. Type of... Yeah, so type of needs to go first, right? So type of this dot energy level is equal to a number. Did you do it like that? You say like this is a number? I think that's correct. We'll see. Then you type in the string, you return the string of my current energy. Energy level is this. Oh, we need two things. We need backticks instead. We need our literal as well, or our $sign and braces. This will then be this dot energy level. And then that, and then encase this in backticks. Okay, let's try that out. No, okay. So did you use an if statement to check this energy level is a number? So I bet that my syntax for that is incorrect. So let's see what they had up here. So they have this dot energy level. Yeah, I'm wondering if it's just, yeah, 3 equal sign would say is equal to, right? Or is a number. This dot energy level and return the correct string inside of the if statement. My current energy level is energy level, this dot energy level. Making sure everything is spelled correctly. Current my energy level is. Okay, replace that with a value. With the value of this dot energy level, yeah, so that should return 100 in there, right? Return 100. Oh, you know what it is? It's because they didn't add a period at the end of their sentence. Did not add a period. That was it. So everything was correct. The string, they were just being picky about that for the instructions, the purpose of the instructions. Okay, so if this dot energy level isn't a number, it could be that the energy property was altered. Let's add a default return statement for when that scenario arises. So we'll need an else that just says system malfunction, cannot retrieve current level, and return that. Ta-da! Okay, so log the result of calling the getter method energy level on robot to the console. Okay, so robot dot energy level, and we don't need the parentheses for this one. Oh, we got to console log it. Console log. Console.log. My current energy level is 100. Yes, indeed. Yes, indeed. All right, those were getters. Now moving on to setters. Along with getter methods, we can also create setter methods, which reassign values of existing properties within an object. Let's see an example of a setter method. So let's see a person, we got their age, we set a new age. If the type of age is a number, this age equals new age, and then console log and else condition if it's not, if new age is not a number. Okay, so yeah, pretty self-explanatory. To use the setter method, you say person.age equals 40, and then you console log the person.age. It did reassign it. The person.age is equal to a string. Then it will log you must assign a number to an age. So what it's doing there, when they put in person.age, it's going to the setter function and seeing the new age property. And so that is what this value is, right? So it's assigning 40 to age, and that's going to be passed through the new age parameter there. And it's going to check to see if it's a number and then reassign it. With this, since they set it as a string, it saw that it wasn't a number, so then it console logged that error message. Okay, so setter methods like age do not need to be called with a set of parentheses. Syntactically, it looks like we're reassigning the value of a property. Like getter methods, there are similar advantages to using setter methods that include checking input, performing actions on properties, and displaying a clear intention for how the object is supposed to be used. Nonetheless, even with a setter method, it is still possible to directly reassign properties. For example, in the example above, we can still set age directly. Yeah, so you can still reassign the, yeah, that still is true. You can still reassign any property that's there manually. I don't know why they keep telling us that. Like, yes, that is still true. You can still do that. Nothing else, like, nothing has changed that. That is a fact. All right, currently in robot, there is a getter method for num of sensors, but no setter method. What if we need to add or remove some sensors? Let's fix that problem. Okay, so add a setter method named num of sensors using the set keyword, provide a parameter of num, leave the function body empty for now. Set, so this is actually going to have the same name as the getter method up there, but this one's going to have a property, sorry, parameter. It's going to have a parameter, and leave the function body empty. A couple of things that we should do in the setter method: add a check to see if num is a number using the type of operator. So if type of this dot num of sensors, or this dot num of sensors, yeah, or this dot num. Wait, please check. Num is a number using the type of operator. Number should be greater than or equal to 0. How did they have it up there? I don't think that you actually need this for. Yeah, no, you don't need this. We're not accessing another property. It's not a property. It's just a parameter of the method. So type of num is equal to then number. Within this, we'll put down that it should be greater than or equal to 0. Oh, okay. So this is the type of num is a number, and do ampersands, and num is greater than 0. Greater than or equal to 0, right? Not sure if that's, I don't remember if you put the equal sign before or after. I think it's after, so that it's not looking like an arrow function. Yeah, so then if both conditions are met, reassign this num of sensors to num. This dot sensors equals num. Okay, now add an else that logs, pass in a number that is greater than or equal to 0 to the console. Okay. Console log this string. Okay, and then use the number of sensor setter method on robot to reassign the number of sensors to 100. So robot robot.number of sensors equals 100. But this is not, it has to have an underscore because that's the property. The number of sensors was just, or no, it doesn't, because you're accessing the setter, right? Okay, so number of sensors would equal 100, yeah. Okay. You could assign it manually like that too, but in this case, it's just accessing the setter and then running that function. To check that it worked, console log it. We shall console log robot.number of sensors. Undefined. Num of sensors robot.num of sensors equals 100. Cool. All right, those were getters and setters. Factory functions. So far we've been creating objects individually, but there are times where we want to create many instances of an object quickly. Here's where factory functions come in. A real-world factory manufactures multiple copies of an item quickly and on a massive scale. A factory function is a function that returns an object and can be reused to make multiple object instances. Factory functions can also have parameters, allowing us to customize the object that gets returned. Let's say we wanted to create an object to represent monsters in JavaScript. There are many different types of monsters, and we can go about making each monster individually, but we can also use a factory function to make our lives easier. To achieve this diabolical plan of creating multiple monsters objects, we can use a factory function that has parameters. So, constant monster factory. Name, the parameters are name, age, energy source, and catchphrase. Then it will return an object with these properties of a name, age, energy source, and catchphrase. This is clever because now, let's go on to the next step. Now, in the monster factory function above, it has 4 parameters and returns an object that has the properties. We saw that. To make an object that represents a specific monster, like a ghost, we can call the factory with the necessary arguments and assign the return value to a variable. Yeah. So then you do a variable, constant ghost, monster factory, and then add in the 4 arguments that you want. And those are going to populate there. That's so cool. And then you only have to, well, you're creating a factory. Yeah, you only have to write this code once and then put in the arguments you want, and it will create those monsters for you. And then you can access the properties of the monster that you just created based off of the variable assignment, right? That's cool. That's really cool. That's clever because it's like, oh yeah, name equals any name, right? Age equals any age. Cool. And then so the ghost variable is the result of the monster factory function. And the result of that is an object that has properties. So then ghost becomes, even though it was just a variable equal to a function, it actually becomes an object. That's the result of the function, and then you can access its properties. So now we have a ghost object as a result of calling monster factory with the needed arguments. With monster refactory in place, we don't have to create an object literal every time we need a new monster. Instead, we can invoke the monster factory function with the necessary arguments to take over the world. I mean, make a monster for us. Yeah. Instead of making individual robots like we've been doing, let's make a factory function to make robots as we please. Yes, create a factory function named robot factory that has two parameters, model and mobile. Make the function return an object. In the object, add the key of model with a value of model parameter. Add another property that has a key of mobile with a value of the mobile parameter. Then add a method named beep without a parameter that will log beep 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 boop to the console. Right, so factory function, first we can create this as a constant robot factory. This will be, hold on, I need to look at that, check back at the syntax of this. I think it's just, yeah, okay, so it's just a simple arrow function with that. There's no difference at the top there. So just model and mobile. And so this would then return an object. With model key, model value, comma, mobile key, mobile value, oops, mobile. And then the last one is the beep method, which returns, or will log, yeah, that will log. So console log beep boop. Okay. Use your factory function by declaring a constant variable named tin can. Constant tin can. The value assign tin can the value of calling robot factory with the first argument of p500 and the second argument of true. So those arguments will get passed through model and mobile, and they'll become the tin cans model and mobile. Okay, so robot factory with the arguments of a string p500 and so comma of true. Those will be the two arguments there. Let's now check as what tin can do. Call .beep on tin can. And this is a method, so but it's not a getter or setter method, so we do need the parentheses there. Yeah, so once you call the beep property on tin can, now that is an object, right? The variable then just became an object. It'll access this property within it and console log the beep boop to the console. Sweet. Play around with tin can to check other properties. Yeah. Yeah, so then you could also console log the model, like the, yeah. So set this within parentheses. This would then become model, and then you could see P500. You could also just, I think, let's see, what happens if you just do console log the tin can? Yeah, it'll show you everything. It'll show you all the key value pairs within it. I wonder if you do tin can dot join, does this work at all? Does not, because join is, or that is not a function. What happens if we do like undefined? Yep, undefined. Interesting. So you can't run the methods that work on functions on objects. Okay. Just wanted to see if it would like add it into like this would become just a string instead of seeing the object itself. Yeah, what if you did like dot mobile and then like comma and then do it again, tin can dot model. Yeah, you can do that. Okay, so if you want to console log multiple properties, you can do it in one line. You just need to separate those properties by a comma. So then we have true, P500, and then we could even put our little beep boop at the end of that. So tincan.beep, beep function. But you need to add in a comma or else it will throw a reference error. Like that, beep boop, and then undefined. That's interesting. It's running an undefined something or other. Tincan.beep. Tincan. Weird. Okay, so what if I just do this then again? Beep boop undefined. What is undefined here? Is this oh, because I don't need to console log that. That's right, because it's console logging already. And this is trying to access something within the function, and it doesn't have the scope for that, right? It only can access what's within the object scope. So so yeah, we can get rid of that. Get rid of that and just have it be those two, true and P500. All right, property value shorthand. ES6 introduced some new shortcuts for assigning properties to variables known as destructuring. In the previous exercise, we created a factory function that helped us create objects. We had to assign each property a key and value, even though the key name was the same as the parameter name we assigned to it. To remind ourselves, here's a truncated version of the factory function. Okay, so the truncated version of the factory function. Yes, yes, indeed. Imagine if we had to include more properties, that process would quickly become tedious. But we can use a destructuring technique called the property value shorthand to save ourselves some keystrokes. Example was, oh, that's cool. Yeah, so since it's just, since the name is just any name, and since the age is just any age, it knows that, like, you can omit the value side of it and just put in the name separated by commas, and then it knows that, okay, you want the value to be the same or to be an ambiguous, an anonymous value of whatever this is called, right? The same word that you're using to describe the key will be the value as well, and how it reassigns that using the arguments you put into it. So notice that we don't have to repeat ourselves with property assignments. Woohoo! So use the property value shorthand and refactor the factory function in main.js. Thank you for the follow. All right, so let's get rid of this and refactor this to simplified version. I think that's all we needed to do, right? Yeah, P501 and false. Hey, how's it going? Okay. Destructured assignment. We often want to extract key value pairs from objects and save them as variables. Take, for example, the following object. Constant vampire. Name is Dracula, residence is Transylvania, and he has some preferences. Stay inside and satisfy his appetite. Hey, how's it going? Welcome to the channel. Your messages are coming through as Cyrillic script. So there you go. Good. If we want to extract the residence property as a variable, we could use the following code. Constant residence equals vampire.residence. Console log residence prints Transylvania. Okay, yeah. So just reassign that. However, we can also take advantage of destructuring technique called destructured assignment to save ourselves some keystrokes. In destructured assignment, we create a variable with the name of an object's key that is wrapped in curly braces and assign it to the object. Take a look at the example below. Constant residence vampire. Interesting. So you add in those curly braces to tell it to find that property within the object and then assign that variable to it because it's the same name. So then residence prints Transylvania. So look back at the vampire's object's properties in the first code example. We declare a new variable residence that extracts the value of the residence property of vampire. When we log the value of residence to the console, Transylvania is printed. Okay. We can even use the destructured assignment to grab nested properties of an object. So this day is like the third layer down, vampire.preferences, and you're grabbing day after or within the preferences. Yes, I'm just learning JavaScript through CodeCademy and on the objects portion of it. Use destructured assignment to create a constant variable named functionality that extracts the functionality property of robot. Okay, if you need a reminder on how to use destructured assignment, review the example. Okay, so this is just, you can just use the constant and then the curly braces named functionality. So functionality, this would then equal, let me get my syntax right here. This is going to be robot within just the one. Let's see. No, I don't. I know very little code beyond what I'm learning right now. I've done little like After Effects and animation projects that have scripts that I've put into them, but not actually coding myself. So I've seen code before, but I've never really written it myself. If you need a reminder on how to use destructors, okay, so robot, we've got the robot. I think that's all that we need for that line. And then on the second line, we'll log that to the console. So call the beep method on functionality. Oh, I see. So then you don't even need to console log it if it has one built in. So functionality, make sure I spelled that correctly. Functionality, okay. And then dot beep. This one will need method parentheses, there we go, like that. Cool. So then you have a variable that we reassigned to the property of functionality. That way you don't need to have to access the whole object, right? Like if you had an object that had many layers, and then you said robot dot, functionality dot beep dot fire laser dot whatever, it can get pretty long. So instead, you just assign it a variable, and then you can speed up the process of calling the methods on that variable. All right. Built-in object methods. Thank you, I appreciate it. Thank you for following and tuning in. So in the previous exercises, we've been creating instances of objects that have their own methods, but we can also take advantage of built-in methods for objects. For example, we have access to object instant methods like has own property, value of, and many more. Practice your documentation reading skills, go check that out. Okay, so there are also useful object class methods such as object.assign, object.entries, and object.keys, to just name a few. For comprehensive lists, browse MDN's object instant documentation. Let's get acquainted with some of these methods and their documentation. You'll see errors as you work through this exercise, but by the end, the errors will be fixed. Okay, so in main, there's an object robot. We'd like to grab the property names, otherwise known as keys, and save the keys in an array, which is assigned to robot keys. However, there's something missing in the method call. Find out what we have to include by reading the documentation. Okay, we'll get to that in a second. Let's look over the code that they gave us first. So we have an object, robot object. We have all the properties within the robot object. Model, mobile, sentient, armor, energy level. Okay, so what's missing from the following method call? Constant robot keys. So they want to grab the property names. They want to grab the keys and save it in an array. Object.keys. Okay. Let's go ahead and check out the documentation here. This is the Mozilla Developer Network documentation on Java. Has literally everything you could possibly want to know about it in here. It's basically the manual. And we are looking at the object.keys. Object 1. Okay, so we need to have... Oh, that's cool. Look at that. when you highlight something within this, it also highlights every reference of it. Nice. I like that. Okay, so all that we need in here is to have it be robot, right? Robot. Okay, I think that's all we need. Model, mobile, sentient, armor, energy level, sweet. So that's what I was wondering earlier, was that how do you put like all the information, all the values into one string or into one section without like printing the whole key value pair object thing. So that's how you do it. You'd use object.keys and then the object that you want it to create an array of. Object.entries will also return an array, but the array will contain more arrays that have both key and value of the properties in an object. Okay. Key and value of the properties in an object. Okay. Declare a constant variable named robotEntries and assign to it the entries of robot by calling object.entries. Okay, so here just constant robotEntries. So this will equal object entries. I'm guessing we need to have it be the same as above, so just put in the robot, right? And see, yeah, okay. So that'll create a nested array, and it will have, the nested arrays will be the key value pairs. So if you wanted it to list like that, you could. And if you just wanted the values, you'd use object keys. Or sorry, duh. Yeah, not if you just wanted the value. If you just wanted the keys, I've been saying the wrong thing. If you just wanted the keys, you do object.keys. But if you want the pairs, the key value pairs, you do object.entries. Yeah, so I'm guessing that this, because we don't see this object word anywhere else, that this is actually a global object, right? Something that's built into JavaScript, and then it's using the robot or whatever you put here as the argument for this, and then that becomes what the object is. Okay, so now if we want another object that has properties of robot, but with a few additional properties, object.assign sounds like a great method to use. But like the previous examples, we should check the documentation before or declare a constant variable named newRobot. NewRobot will be a new object that has all the properties of robot and the properties in the following object. Laser blaster, true. Voice recognition, true. Make sure that you are not changing the robot object. Okay, declare the new robot down here. Constant new robot. New robot. That has all the properties of robot and the properties of the following object. So we need object.assign, right? Object.assign. But we don't want to change the current object. So let's check the documentation on the assign. So we have 2 parameters instead of 1. So we have a source object, or a target object and a source object, right? Then we create a variable and we say that we want the target to be added to the source. So then expected output would be 1, 4, and 5. Return target equals target. That's true. Okay, so this is like overriding the 2, right? So it's saying that it's assigning. Okay, I think I understand. So it's assigning the parameter or using the object information as the second parameter, right? So then it pops up as 4 and 5, taking the place, both of those are taking the place of B2. Let's see if we can think about it that way and then do robot, and then this object, laser blaster. I don't know if we can add that whole be a new object that has all the properties of robot and the properties in the following object. Laser blaster true, voice recognition true. So how do we write this? Do we create another object first? Do we say that laser blaster is its own object? I think so. Or we could try to copy it within that parameter. I have no idea if the parameter can accept an object. We'll see if it can. Let's double check the documentation on the assign and see target and sources. So we're adding, oh, I see. So this doesn't need to be, target and sources. The semantics are a little bit confusing at the moment. Let's see. So our target is the robot, right? Is that robot object. The return target is the new robot. But then you reassign, what's happening is then you reassign the target object. So we don't want that to happen. We want it to only assign to the return target. So let's see what to apply the source's properties to, which is returned after it is modified. The source objects containing the properties you want to apply. And then the target object. Okay. Properties in the target object are overwritten by properties in the sources if they have the same key. Later sources of properties overwrite earlier ones. Object assign only copies enumeral and own properties from a source object to a target object. It uses get and set on the target, so it will invoke getters and setters. Therefore, it assigns properties versus copying or defining new properties. Unsuitable for merging new properties into a prototype if the merge source contains getters. Okay, so just a note for later, don't use getters when you're using this method, but I don't think that applies to us. I think that we can still, both string and symbol properties are copied. Examples. So if you're making a copy of an object, you use an empty object and then object. Oh, okay, cloning an object. That's what you need to do, right? For deep cloning, we need to use alternatives because object.assign copies property value. So if the source value is a reference to an object, it only copies the reference value. Source value is a reference to an object. So let's see. Source value. It only copies the reference value. Object 1 is that string. I'll take a look at this later. I don't think this is actually what we're doing right now. I think we're just doing the simplified version. So so we need an empty set of curly braces, just empty braces at the beginning. That makes more sense because they're saying target. And I was like, well, I don't want to change the top one there. So let's just try that and see. Almost, but we just had a, yeah, so we need to add robot as one of the sources, right? Robot needs to be added in there too. There we go. Yeah, so it can accept multiple sources. That sources section of the assign syntax can be however long. So like this source, you can have 100 if you wanted. And then the target, if you're assigning it, simply creating a new object from scratch or a new object by adding together one that already exists and then new properties, you want to put an empty set of braces at the beginning so that it'll create a new object and not reassign one that already exists. If you put the target as robot, then it will reassign some of these if there's duplicate key names. But yeah, this just makes it easier. So empty curly braces and then your sources added together. And that will console log everything that we want to see. So now we got the model, mobile, sentient armor, energy level, laser blaster, and voice recognition. All right, congratulations on finishing advanced objects. Congratulations, everyone. Let's review the concepts covered in this lesson. The object that a method belongs to is called the calling object. Use this keyword. This keyword refers to the calling object and can be used to access properties of the calling object. Methods do not automatically have access to other internal properties of the calling object. The value of this depends on where the this is being accessed from. We cannot use arrow functions as methods if we want to access other internal properties. I don't know why you would want to, since it's just a shorter, shorthand anyway of that. I don't know what the benefit would be to using an arrow function within an object versus a method. JavaScript objects do not have built-in privacy. Rather, there are conventions to follow to notify other developers about the intent of the code. Yes, there's no built-in encryption that you can make things inaccessible. But you can let people know that things are not meant to be changed, right? We'll also see that later in some of the other game dev projects where they put the underscores. The usage of an underscore before a property name means that the original developer did not intend for that property to be directly changed. Setters and getter methods allow for more detailed ways of accessing and assigning properties. Factory functions allow us to create object instances quickly and repeatedly. I am most excited about this one. That has so many possibilities in my mind. There are different ways to use object destructuring. One way is the property value shorthand, and another is destructured assignment. Also very cool, the property value shorthand. As with any concept, it is a good skill to learn how to use the documentation with objects. All right, you ready to start leveraging more elegant code for creating and accessing objects in your code? There are some optional challenges if you want. Find the value of this function inside of a method. Learn the outcome of using a property that has the exact same name as a setter and getter. Yeah, this is going to throw a reference error. We did a new factory function before. We did the documentation and built in other methods. And you can go ahead and play around with other methods if you would like to access that Mozilla Developer Network page and check out the manual for JavaScript. But for now, we are finished with advanced objects. And let's see what we got for time here. I think that's a good point to end it. We will do our meal maker project next time. And I think we also have two projects to do after this. We have our meal maker and then team stats, and then we have a quiz. I kind of want to do the quiz now because it's fresh on my mind, but we'll wait on that. We'll wait, and we'll do that hopefully tomorrow. After that, we definitely have another game dev project. I'm always excited about those. I hope it will be a little more fun than the cube measure. Man, that was rough. But hey, we did the objects. We learned about those and advanced objects. I hope you all were able to follow along and pick up something if you did watch. But anyway, have a good one. Live long and prosper. And I will see you later.